Okay. We have gone over a straight path that extends forever in two directions. That's called a line. We've gone over a common endpoint or a corner of an angle. That's called the vertex. All right, let us continue. If you guys can watch right there, perfect. This one, oh my gosh, this one always gets me too. This one frustrated me when I was in high school, actually. What is an exact location in space, but it has no dimension? I always was like, this is impossible. How could something with an exact location have zero dimension? Like it's not one dimension or two dimensions or three dimensions or fourth dimension or infinity dimensions. It has no dimension. What is that? What is that called? Someone know? Point. Alex, awesome job. This is a point. All right. I would argue to say the point is one of the most foundational terms in geometry. There are, in a line, here we go, I'm going to say the I word again. In a line, there is an infinite amount of points. Infinite. Never ending points. So if we were to get and focus on one of them, one exact location in space, yes, this would be point A. Now, if we could tangibly see geometry, like, oh, there's a line that's extending forever or anything, since this point has no dimension, we wouldn't be able to see it. We would just kind of point at it. Get it? Point. Haha, dad joke. Rank that one, Natalie. All right. The name is point A. I don't want to get sidetracked. All right. An exact location in space has no dimension. That is a point. Okay. 4. A flat 2D surface, I love this one, that extends in all directions. A flat 2D surface. I told you guys my drawing is terrible. My artistic skills. That extends forever in all direction. Anyone shout out? Know what that is? 2D. That is called a plane. All right, plane. So if this was plane A, B, C, D, this would be plane A, B, C, D, a simple way to name it. I always like to think of this, guys, of a plane as, very simple, piece of paper, right? Think of this piece of paper. Look, it's 2D. It has length and width right here. Now, obviously, this piece of paper has a depth. Right? Even though it's tiny, because we can see it, obviously it has depth. Think of a plane as a flat 2D surface that extends forever in all directions. So think of it as there's no depth. It's just a plane left and right, length and width right there, length and width. And so this piece of paper just goes out flat in every direction, right? That's a plane, okay? Lines that cross at a common point. This is why I love geometry. Because a lot of these terms are not meant to confuse you guys. Right? They're not trick questions. If you guys look at the word bank, right? And you're like, okay, it's definitely not polygon. It's definitely not obtuse triangle. It's definitely not 180 degrees. You can maybe use just a little bit of common sense or process of elimination. Be like, what are lines that cross at a common point? Well, those are just intersecting lines. It is extremely general term, but we're going to be dealing with a ton of intersecting lines. I mean, we have already. Think about all the graphing that we did. Guys, think about the systems of equations, right? Like 2 months ago or whatever, when we were graphing a system of equations, those essentially were intersecting lines, right? And that solution of that system was where it crossed, right? The intersection point. So lines that cross at a common point, those are lines that intersect. There's really not a name for it, all right? Just know that any two lines that cross, they have a common intersection point, okay? lines that intersect to form 90-degree angles. My favorite angle is a right angle. It is a 90-degree angle. And I already just gave it away. Oops. Lines that intersect to form 90-degree angles. I'm going to draw right here. I'm running out of paper here. If I have lines that intersect to form 90 degrees, someone give me a shout out. What little thing do I put in the corner? I know you guys have seen this before. In the corner of these two lines, to designate this is a right angle, 90 degrees, what do I put? I heard a teacher the other day say, I can outweight you. As in, I'll just wait. Now, I'm sorry, I'm not looking at the chat. So if someone put it in the chat, thank you. It is a little tiny box right there. Oh, Raina, awesome, Raina. Thank you so much, Raina. I was not ignoring you, I promise. When I'm sharing my screen, I can't have the chat doesn't work for me for some strange reason. I have to unshare, all right, for it to really work. So, yeah, little box. So guys, whenever you see that little tiny box with anything, even though my drawing, it doesn't really look like it's a perfect cross or a perfect L, if I have that little box, for sure, that means it is a 90-degree angle, all right? So lines that intersect to form 90-degree angles, right angles, all right? And then you would go to your word bank and cross that off. Okay, I'm gonna get a different piece of paper because I'm running out of room. Let me make sure my phone is still recording. Yep, sweet. All right, we're almost halfway done, guys. What time is it? Okay, we got time. All right. Any questions so far? Ladies and gents, once again, this is what I assigned on Thursday of last week for you guys to try on your own. And it's okay. Even if you turned it in, and I saw some of you guys that turned it in, some of these were wrong. That's not, I'm not grading it for correctness yet, right? That's for our test next Tuesday. I wanted you guys to try it on your own to see how many you got right? So that way we can see when we go over it, this extension of our pretest. When I actually, this unit, I've always done it this way. I really didn't teach you guys this like I am now last week. Remember, we had the Quizlet, we had the flashcards, and then we had the pretest. This is something to where I wanted you guys to really kind of try on your own and see what you remember. Because you might have been taught this before, like in 7th grade or 8th grade. But if not, this is why we're here. Here we go. 7 lines that are in different planes, never touch, but they're not parallel. This is another one that just grinded my gears when I was in high school. I hated this term and this vocab because in my mind, lines that never touch, guess what? It starts with a P. Yeah, teacher. Lines that never touch, easy. Those are parallel lines. Parallel. But what the heck? These are lines that never touch, but they're not parallel. Well, what the heck are they? Skew. Mr. Lawson, very well done. All right, I might actually have to give you real extra credit, Alex. Good job. Skew lines. And how I remembered this is that just the name, skew, that's how I remembered it. Just the name skew is just odd, and it's weird, and I don't like it, all right? Here's how lines are skew. All right, I'm gonna do a little if you're watching on the recording, you can't really see it. Let's pretend this line is right here, this yellow line, okay? It is going, what is the line? Forever in 2 directions, okay? This line is only extending in 2 directions. Think of it this way. Pshow to the left, pshow to the right, all right? Think of this line. What if there's a line kind of tilted, but it goes like this. So I'm going to rotate. Hey, do you guys see how this, oh man, this is perfect. I wish I had done this with first period. I didn't do that. If I take these two lines, there's two lines right here. This line that's going this way, in two directions, will it ever cross this line going like this? Never, right? In two directions, up and down here, will never cross with this line going in two directions this way. Because the key point is that they are in different planes. So these lines will never touch, but there's a flat 2D surface plane right here. There's a flat 2D surface plane right here. Now, guess what? Their planes may intersect. Yeah. Wait, no. Oops. See, I already confused myself. No, their planes won't intersect either, but the lines will never intersect, right? So they're not parallel because they're in different planes. Now, here we go. If we have two lines that are in the same plane, like this, okay, you see how they're in the same plane, never touch, that's when they're parallel, right? So that's the best way that I've remembered what skew lines are, right? They never touch, but they're not parallel because they're in different planes. So it's, drawing, I'm going to butcher this. I don't know. I can't even. Terrible drawing. Name, there's not really a name for it, just skew lines. I gave it away. That whole big speech. Here we go. Number 8, lines in the same plane. I'm not going to take too long on this. We all know what it is now. Here's a plane. This is a good way to describe it, actually. If they're in the same plane right here and they never touch, yes, those are parallel lines. And I want to go back to number 6 because I want to tell you guys something. I missed a word in there. These lines let's look back at number 6, these lines that intersect to form 90-degree angles, the lines themselves are called perpendicular lines. So if you go back to number 6 real quick, I was so excited about the right angles and thinking about trigonometry and right triangles and you guys in integrated math 2 next year. The lines themselves are called perpendicular lines, where lines that never intersect are called parallel lines, right? So perpendicular, intersect to form 90 degrees. Parallel, never intersect, all right? And if this is line A, line B, if you ever see this little 2, this little icon right here, it's not 2 eyes or the number 2. It's just a little icon that tells you, hey, A and B are parallel to each other, if you see that icon. Okay, another reason why I love geometry. Vocab, triangle with 3 acute angles. There is no... Alex, you already unmuted yourself. What is it? Oh my gosh. Guys, I would... Alex will go take money from his mom's purse again and give everyone not only $5, but $10 this time if everyone given a word bank could maybe figure this out, right? It is what it is, right? So much of these vocab, the answer is in the name. A triangle with 3 acute angles, and we're going to go over what acute is in a little bit, is an acute triangle. Pretty easy. Easier than 2 plus 2, I think. All right? There's no trickery. We don't want to trick anyone in this. Here we go. All right. Part of a line, but it has 2 endpoints. All right. Emphasis on endpoint. All right. This section of a line that has 2 endpoints is called line segment. Okay. Think about it. It kind of makes sense because a segment is a portion of something, right? And portions end. This is not infinite. In fact, it is finite. finite means that there's a limit to it. It ends. So a line segment has two endpoints, right? And if this was point A and point B, we would name this, or just, label it AB for my points, and then a little line segment icon above it, right? And hold on. That's different. If you guys look at what you wrote down for number 1, look right here. That's different than this label. Like if we have two arrows, this is a line, we would name it AB and then the arrows up top. For a line segment, AB, we would name it, and just put the segment up there. That's number 10. Oops. Number 9, I didn't really draw. Well, I'll draw it right here. Now I'm starting to get unorganized. Sorry, guys. An acute triangle is a triangle with 3 acute angles. And acute, we're going to define later, is less than 90 degrees. So an acute triangle has 3 angles. All of them, each of the 3 are less than 90 degrees. All right, that's number 9. All right, we're almost done, guys. 4 more. Triangle. Love this one. Oh man, I love these triangles. These are my favorite. And yes, I'm going ultra nerd today because I'm gushing over math. All right, a triangle with one 90-degree angle, and like we said up here, like in number 6, a 90-degree angle is also called a right angle. So guess what? A triangle with a right angle, right triangle. Alex, I'm serious, man. I'm just having you teach the class, dude. Good job. Thank you. And I mean that with all sincerity. Good job. 11. Triangle with one 90-degree angle is a right triangle. A right triangle is a triangle with one 90-degree angle. Okay, just like this. Now, what designates, if you were just to see this versus this, this right here looks like a 90 degree. That looks like a perfect, L shape. Why is this one not a 90 degree, not a right triangle? Someone besides Alex, maybe. Why is that one, I know you guys know this. Why is this one not a right triangle? What is it missing? The answer is right to the left of it. Right, left. Dad joke, get it? Natalie, that's definitely an 11. This little box, right? In geometry, you can never, ever, this is the cardinal sin in geometry. I'm going to say the A word. In geometry, you can never assume. That's the A word. Never assume. If it looks like it's a 90-degree right triangle, but it doesn't have my little box that I know designates it, we cannot assume it's 90. It might be 89.1. If it's 89.1, is it a right triangle? No. All right. This will be huge later on in integrated math 2 or 3 or in college when you start doing proofs, where you prove stuff. Like prove, I'm going crazy right now. Prove that's a square. You have to prove it with theorems and postulates. Oh, good stuff. Okay. Later on, guys, don't worry. Number 12. A triangle with one obtuse angle. Once again, guys, the triangles are super easy to name and learn. A triangle with one obtuse angle is an obtuse triangle. I know, shocker, right? An obtuse triangle, if you guys can see it on the bottom here, I'm going to move up, is a triangle with one obtuse angle. With one obtuse angle. What is an obtuse angle? An obtuse angle is any angle between 90 and 180. Notice I put 91 to 179, but I really meant 90 to 180 because it could technically be, 90.1 to 179.9 degrees, right? It's not 90 or it's not 180, it's just in between. So that's an obtuse angle. An angle measurement between 90 and 180 degrees. 90, obviously, is right here. 180 degrees is right here. What's crazy is that 180 degrees is a straight line. And we're going to be going over a lot about that. A lot after spring break. Okay. 2 more. Another word for equal or same when they have the same measure. All right, I'm not going to really write anything down. I just want you guys to know that this word exists, and you guys have probably used it a lot. Congruent. If measurements or line segments or anything is congruent, that means they are equal in general terms. Now, there is something that they do to break down congruent versus equal, but just know that when you hear congruent, they are the same measure. Okay, so if this is 61 degrees, and a separate angle is also 61 degrees, when you hear the word congruent, hey, these are congruent, that means they're equal, they're the same. K or ace. Whew, man, I told you guys this might go a little longer today. Totally fine. Last one. And this is a good one to end on because it's probably one of the most important of the 28. Angles that are opposite each other but have the same vertex. Alex, do you know what this one is? Yes. No, you're totally fine. It is something angles. Not adjacent because this key word right here, opposite, right? So they just have they're not called opposite angles. That would be kind of too easy. These are vertical angles. And here's how I always think about it. Angles that are opposite. So here's an angle right here. Ooh, this highlighter has seen better days. Look at that. It's almost dried out. Actually, this highlighter has been open for like a week. I'm surprised it still works. There's an angle right here. All right, opposite is on the bottom, like that. So this angle right here and this angle right here, those are vertical angles because they share the same vertex. Uh-oh, look at number what? 2. What's a vertex again? A vertex is the point where lines or angles share intersection. Right? So angles that are opposite but share the same vertex. If we go right here, this angle right here, so Alex, this is perfect. This is how we're going to conclude the class. You said something A. You started with an A, not angles, but what'd you say? Adjacent. This one right here, this angle, the purple, to the red, that is what adjacent is. Because if you think adjacent, right next to each other. Adjacent angles, and this is a definition for later on, adjacent angles are right next to each other, whereas vertical angles are opposites, but they share the same vertex. And to conclude, I want every single one of you guys to write this down. Vertical angles are always, I'm looking for one of 2 words, and I will give this person a big, nice, juicy wampum card if they say it. Vertical angles are always what? So this angle and this angle, top and bottom, are always what? Someone give me a shout out, please. They are opposite, but I'm looking for something else. Anyone? Take a stab. I'll give you a hint. Look at the measurements. That's a big hint. So, Alex got it. Oh, Faith got it too. Faith, you're awesome. Thank you so much. Alex, and you got it too. Thank you guys for being brave. Vertical angles are always the same measure. AKA, vertical angles are always congruent. Pretty cool, huh? Always. If angles are vertical, there is nothing that makes them not congruent, right? Whenever you have any vertical angle, two angles that share the same vertex but are opposite each other, they are always the same and congruent. Those two in the red, those are vertical angles. They're the same. Guess what, guys? There's another pair of vertical angles. Where is it? Oh, snap. Those are vertical angles. There's two sets of vertical angles right there. Pretty cool. I think it's pretty cool because I'm a math teacher. All right. Guys, wow. That's probably the longest Zoom we've had in a while. So I really appreciate you guys sticking with me. I'm going to move this down, and stop my share, stop my video. All right, perfect, awesome. Okay, adjacent angles that are side by side, they share the same vertex. So obviously that vertex is that point like we defined the other day. Okay, moving on. All right, this one is a hard one because a lot of students get it all mixed up. It's either complementary angles or supplementary angles. What is the difference? We have complementary angles, and then we have supplementary angles. One of these adds up to 90 degrees. The other adds up to 180, right? So we're going to officially define it, and then I'm going to tell you guys how I remember, a little trick. So two angles that add up to 90 degrees, those are called complementary angles. All right, so for example, if I had a 40-degree angle right here, and then if I had a 50-degree angle, well, if I put those two together, it'll probably look something like this. Oh man, if I add these two angles together and they equal 90 degrees, those are complementary angles. Two angles that add up to 90 degrees. And remember, 90 degrees, that's that little box right there. That means it's a 90-degree angle. Here's how I remember it. This is a simple, tiny little trick that I remembered when I was in high school that I'm going to tell you guys. All right? Complementary. See this C-O-M right here? C-O-M-P-L-E-M-E. This is the C-O. In my mind, I just do this. Draw a little line down the C. What the crap, Mr. Wallace? What does that look like to you guys? Someone should give me a shout out. What does that look like right now? What did I just make? A Q. Well, yeah, a Q, but also it is a Q, Gabriel. Yeah, you're right. But a 90, right? Well, oh, look. And complementary, if I draw just a little line, that's a 9-0 now, up two angles that add up to 90 degrees, all right? So I'm going to write that out again. I'm just going to put comp. There's my complementary angles. In my mind, if I just quick draw a little line, I have what looks like a 9-0 right there. So 90, right? Complementary, 90 degrees. That's how I remember it, okay? Now, obviously, just by process of elimination, two angles that add up to 180 degrees, those are called supplementary angles. There we go, right? So supplementary, for example, is, let's just say if we have like 120, that is a crazy angle. The paper did that, guys. I promise I can do a straight line. if we have a 120 degree angle and like a 60 degree angle, well, if we add those up, that's 180 degrees. And what's cool is that a 180 degree line or angle, it's a straight line. Think of it as half a circle, right? 360 degrees is a circle divided by 2. Well, that's 180 degrees, just right there. Another really cool reason I love geometry, stuff like that. Okay. Oh, here comes Ryder, he got kicked. Okay, moving on. I'm gonna put that up a little bit. A triangle with two congruent sides. So a triangle with two congruent sides. Whenever you guys see these little hash marks, that means that it is congruent or the same, right, equal to its corresponding pair. So if I see a little two hash marks right there and another two hash marks right there, that means both of these two sides are equal. So when we have a triangle with two congruent sides, that is called an isosceles. I don't know if I spelled that right. Oops, that's why I teach math. Isosceles triangle, two congruent sides. All right, a triangle with no congruent sides. You know, here's how I remember it. Remember skew lines? That was number, what number was that? Number 7. Skew lines are lines that are in different planes. They never touch, but they're not parallel, right? In my mind, I always remember that a triangle with no congruent sides. So it's some weird looking triangle kind of thing like that. None of the sides are congruent. Those are called, that's a scalene triangle. And I just remember the S. You know, skew lines, scalene triangle, no congruent, not parallel. That's how I make that connection. So triangle with no congruent sides, scalene. Excuse me. A triangle with 3 congruent sides. Here we go. So this is number 20. If we have a triangle, here we have hash marks. Okay, so another kind of little hash mark thingy. That is designated that each of these sides are congruent. They are the same. So a triangle with 3 congruent sides is called a equilateral triangle. I almost forgot for a sec. And the way I remember this, see the equal? I mean, literally, part of the answer is in the name again. 3 congruent or 3 equal sides is an equilateral triangle. Okay, angles that measure less than 90 degrees. All right, so this is number 21. An angle that measures less than 90 degrees. Well, we know a 90-degree angle is a perfect L, right? A perfect L with a little box. That's a right angle. Does anyone know this? Unmute and give me a shout out real quick. Does anyone know what an angle is called that's less than 90? Yes, awesome, Gabriel, awesome job. It is an acute angle. So obviously any angle that is less than 90 is called an acute angle. Here's a question for you. So Ryder, I'm gonna ask you, Ryder. If I have an angle that's 89.9999999, the 9s go to infinity. 89.9 to the infinity. Is that still an acute angle? And sometimes I know Ryder's mic doesn't work, and I can't check the chat. The answer is yes. Even though it is 0.0 infinity 1 away from a 90-degree angle, it very much looks like a 90-degree angle. It's still an acute angle. It's not 90. So, sorry, infinity. All right, number 22. Has one endpoint, okay, endpoint, but extends forever, forever in one direction. Isn't that a band? One Direction? I made another dad joke. That is called, someone want to unmute and go ahead? What do they think it's called? I have no idea why they call it this, by the way. What is this called? Yep, it is a ray. Good job again, Gabriel. Awesome job. All right. If we ever have something in geometry to where it does have an endpoint and extends forever in one direction, that is called a ray. All right. And here's how we name it. So remember, if we have a line, we have arrows on top of the letters. If we have a line segment to where there's two endpoints, we just have a line segment on top of the letters. But we name a ray, we have to put its endpoint first. So this is A, B. So whatever letter is where the endpoint is, that's what you have to put first. And then you put a little one arrow like that. So that is how you name a ray. So if you see this somewhere, either on a test or something, this is called ray AB, and it's labeled just like that. Okay. One endpoint extends forever in one direction. That's a ray. All right, guys, we are almost done. Almost done. There we go. Just a couple more. And that way, then you have the full vocab in prep for Tuesday. All right, I'm going to move this. We have 1, 2, 3, 4, 5, 6 left, and then we're done. Okay, don't worry, guys. On our test on Tuesday, this word bank is going to be here. All right, I promise it will. You guys will have that. I would love for you guys to be able to know without looking what something is, but that's why I'm teaching you it. All right, because over time, I would want you to know that, hey, points not on the same line. I know what that is without even looking at the word bank. All right. Okay, number 23, angles that measure exactly 90 degrees. Angles that measure exactly 90 degrees. We have that little box. You guys probably know this already. We've already talked about it so many times. Those are called right angles. Right angles are so important in geometry. Ooh, especially trigonometry, which you guys will be doing next year in Integrated Math 2. Woohoo. So exciting. All right. Right angles. Number 24, a closed plane figure. Okay, interesting. Closed plane figure. Formed by at least three or more line segments, a shape that is called a polygon. Poly just means many, and gon means, this is not Hunter x Hunter, means sides. Polygon, many sides. A polygon is the most general geometric term. All right, it's like the umbrella term. Because think about it. Polygon, it could be a triangle. A polygon could be a square. It could be a octagon. It could be a decagon. Anything. It could be anything. At least three, right? Could a polygon, I'm going to propose this question to you guys, could a polygon ever have two sides? Someone tell me real quick. Why is it three or more? What about a polygon with two sides? Don't leave two left out. Does someone want to take a stab at it? Well, if there's just two sides, okay, let's try to make a shape with two sides, huh? Uh-oh. Crap. Do we have a shape? No. What do we have? We have an angle. right? It's just an angle. That's not a polygon, and it's open, right? There's open air right here. That's why polygons have to have at least 3, because once you put in a side right there, it is a closed figure, right? A square is a polygon, closed figure. A pentagon is a closed figure, polygon. A trapezoid, closed figure, polygons, okay? There you go. Here comes Christian. All right, angles that measure above 90 degrees. Here we go. So we had acute angles that are less than 90. Right angles are exactly 90. What are above 90? Yes. Awesome job, Alex. Thank you, sir. Obtuse angles. And I just think of obtuse as big, above 90. That's how I remember it. Obtuse angles are above 90 degrees. So, for example, boom. There's an obtuse angle. All right, 3 more, and then we're done. Points that lie on points that are on the same line. Okay, here we go. So I'm going to draw a figure down here. If I have a line, here we go, a line, it extends forever in 2 directions. Remember what a line is. If I have points R, H, W. Oh man, why did I use those? What do you guys think? Why did I use RHW? I could have named it anything else. Ryan, Harrison, Wallace. That's not my name, but I just made it up, right? So points that lie on the same plane are called collinear points. Emphasis on C-O, right? They're joined. They're on the same line. And there's linear right there. So once again, the answer is kind of in the name already. Collinear points. Here we go. Points that lie on the same plane. So here we go. Once again, we have a plane that's 2 dimensions, right? Extends forever in all directions, but it's only 2 dimensions. That's a plane. If I have Stephanie, Marge, Wallace, my sister's initials, those points that are on the same plane are called coplanar points. I'm sure there's a dad joke that has to do something with coplanar. Complain, coplanar, whatever. Finally, to conclude our essential geometry vocabulary, guys, you guys are awesome. The interior angles of any triangle. I don't care what triangle you could ever make. Right triangles, obtuse triangles, isosceles triangles, scalene triangles, whatever triangle you make. Infinity amounts of triangles. Here we go. Infinity amounts. The interior angles always add up to 180 degrees. I guess I should have used a yellow highlighter. I wasn't crossing that out. Always. Emphasis, circle or write down the word always. Very important to know later on this semester and also next year when you guys are in Integrated Math 2. And you guys probably already knew this already. Always, no matter what triangle you create, no matter what kind of triangle it is, like I said, right triangle, isosceles, scalene, equilateral triangle, if you take each angle, this angle plus this angle plus this angle, it's 180 degrees. This angle, this angle, this angle, if you add up their measurements, 180 degrees. This angle, this angle, this angle, you guys get the point, right? 180 degrees. And just like that, everyone can breathe a sigh of relief. Mr. Wallace has concluded teaching the essential geometry vocabulary.